students. So in this video today we are going to learn more properties of Laplace transforms. So in the last video we watched or we understood what is the definition of Laplace transform and what are the three properties of Laplace transform. So we also saw that how we are going to prove these properties, right? So what was our first step there? We started this proof by taking LHS and then by defining the Laplace transform, substituting the value of f of t and simplifying it to get RHS. So that is very simple way of proving the three properties what we mentioned in the previous video. Now in this video we are going to see the other properties of Laplace transforms which are going to be a little bit different from the three properties what we discussed in our previous video. So the fourth property here, it's called first shifting property. First shifting property. So what does this first shifting property mean? So it means that if Laplace transform of f of t is equal to f of s. Now please see that we are mentioning it as f of s and not 0 to infinity e raised to minus st f of t dt, because we are trying to make things simpler. Alright, so now the property says that if Laplace transform of f of t is equals to f of s, then Laplace transform of e raised to at f of t is equals to f of s minus a. Right? Now you know why we mentioned it as f of s. Alright? Okay, so let's prove this now. So what is our proof? And how are we going to prove this? Our first step. What is our first step? Define Laplace transform. So what is Laplace transform of f of t is equals to 0 to infinity e raised to minus st f of t dt. This is our definition of Laplace transform. But what do we have to prove? So the first thing we have to take is the LHS. So what is the LHS? Laplace transform of e raised to at f of t. This is our LHS. So now what do we have to do? Now when we had f of t, we wrote it as e raised to minus st f of t. Now when we have e raised to at into f of t, we're just multiplying this factor e raised to at in this equation or in this expression. Right? So let's multiply 0 to infinity e raised to minus st into e raised to at f of t dt. Now, we all have studied the law of indices or the law of exponents in our school days. So now, if you see these two factors or these two terms, e raised to minus st and e raised to at, the bases are the same. So when the bases are the same, the exponents get added up. This is the law of indices. So that means if we have a raised to m into a raised to n, it is equal to a raised to m plus n. This is what we have studied in law of indices during our school days. Right? So the same thing I am going to apply here to simplify this expression so that I can integrate it. Alright? So 0 to infinity. So what do we have? The base is going to remain the same and the exponents are going to get added up. So minus st plus at into f of t dt. Alright. Now, from this expression or from this term, what I'm going to do is, I'm going to take the minus sign outside and we have t common. So this t also we are going to take it outside the bracket. So how are we going to write that? 0 to infinity e raised to minus, I'm going to remove it out, and then what is left here? S. I'm not going to take t inside because t also I'm going to remove it outside, but on the other side of the bracket. And why I'm taking it on the other side of the bracket, you'll get to know soon, right? So what is left here now? This is a plus sign, minus is taken out, so minus into minus is plus. So this is s minus a into t, right? So what is left here now again? F of t dt. So let this be equation number 2. Now if I compare equation number 1 and equation number 2, are these both same? Obviously, because where I have s, I have s minus a. Minus is there outside. Instead of s, I have s minus a, and t is also in the same place, f of t dt. Everything is same. So that means s is equals to s minus a, right? So if this is equal to f of s, then this will be equal to f of s minus a. So if s is equal to s minus a, this will be equal to f of s minus a, and this is a RHS. Isn't it very simple? Let's move on to the fifth property. So what is the fifth property? The fifth property is called as change of scaling property. Again, in this property, we are having a condition. And what is the condition? The same thing, that is if Laplace transform of f of t is equal to f of s, then Laplace transform of f of t is equals to 1 by a f of s by a. Or you can write small f bar, right? Alright, so when you just see this expression, the first thing you may feel is that, oh, maybe it is a difficult one to prove because you have this particular substitution in the function itself, right? So now let's see how difficult it is. Alright, so what is our first step? Define Laplace transform. Laplace transform of f of t is equal to 0 to infinity e raised to minus st f of t dt. So this is our first expression. Laplace transform of f of t is equal to 0 to infinity e raised to minus st f of t dt. And the next step is substitution. So what is our substitution now? Laplace transform of f of at is equal to 0 to infinity e raised to minus st f of at dt. Now, this is difficult to simplify because we have nothing to simplify here. We have e raised to minus st and we have the function which is with respect to a constant and a time. What we have to do here is we will take the help of mathematics. So in mathematics, when we fall into such problems, the first help we get is from substitution method. So what are we going to do? We're going to substitute AT as U. So let AT is equals to U. Now if AT is equals to U, what will be T equals to? T will be equal to U by A. T will be equal to U by A. Is this enough substitution for us to solve this problem? No. We also have to change this also, because if all are with respect to U, the integration also has to be with respect to U only. So let's see what is the value of dt. So for that, we will differentiate this equation. AT differentiate AT is equals to U. Now A is a constant and differentiation of T with respect to T is 1, and differentiation of U with respect to T, it's going to be du by dt. So what is dt? What is dt? It is 1 by A into du. So now we have got the value of T, we've got the value of AT, and we've got the value of dt. So now we can substitute these values here. Let's substitute. What will we get? We are getting 0 to infinity e raised to minus s into, what is t? U by A. And what is f of AT? It is f of u. And what is dt? It is 1 by A into du. And what is 1 by A? It is a constant. So this constant, I can remove it outside the integral sign. Plus, what I can do is, I can write this in the form of s by A into u. So that is 1 by A, 0 to infinity, e raised to minus s by A into u, f of u du. Now compare equation number 1 with equation number 2. Right? This is equal to f of s. Right? Now if you see this expression, this is with respect to t and this is with respect to u, but both are looking similar except for the value of s. So there, instead of s, I am having s by A. So if I substitute s here, it is going to be e raised to minus su fu into du. So both are the same expressions but with a separate function. Function with respect to t, function of time t, and function of u. Right? So now, can I write f of s as f of s by A? Yes, I can write. But there is one more thing outside the integral sign. What is that? 1 by A into f of s by A. And is it our RHS? Yes, it is. So we have this is equal to RHS. So we followed the same method again, but in between we did something called as substitution. We took the help of substitution method, which we usually take while doing differentiation and integration. So this is our savior in solving this problem. So I hope you've understood the properties of Laplace transform. There are 5 properties of Laplace transform, out of which the 3 properties, the third property, fourth property and fifth property have a name for themselves. The third is called linear property, fourth is called first shifting property, and the fifth one is called change of scaling property. I hope it is clear. If you have liked my videos, please do subscribe so that you will get notified for the further videos. So in the next video, I'll be talking about a different solutions to Laplace transforms. right? So there will be some Laplace transforms or some standard functions we are going to learn in that video, so which are going to help us in the future of solving complex Laplace transforms. Thank you. Do subscribe and do comment if you have any doubts. Thank you.